This graphic shows our roadmap for mastering powers and exponents today. We are going to start with the core concepts, prove exactly why the math rules work so you don't have to rely on memorization, and then test those rules by solving 3 examples, from easy to advanced. Let's start with a power. In this expression, the large number resting on the bottom is your base. The smaller raised number is your exponent. The exponent is simply an instruction. It tells you exactly how many times to take the base and multiply it by itself. Because our exponent is a 4, we multiply 4 2's together, giving us a final answer of 16. When you see an exponent of 2, we call it a square. When the exponent is a 3, we call it a cube. This brings us to the most common mistake beginners make. You never multiply the base by the exponent. 2 to the third power is not 2 times 3. It is 2 times 2 times 2, which gives you 8. Exponents are entirely about repeated multiplication. They are a shorthand notation used to compress long strings of identical numbers into a single, clean package. Once you know how to read that shorthand, you can solve larger equations. The algebraic rules for powers look complex, but we can prove exactly why they work by breaking them down to their basic parts. Here, we are multiplying 2 powers that share the exact same base of 2. If we expand both parts, we get 3 2's grouped with 4 2's. By joining them together, we are left with a single, continuous string of 7 2's. We can compress that back down into a single base with an exponent of 7. This proves why, when multiplying identical bases, you simply add the exponents. The exact same logic applies in reverse when we divide. Expanding this fraction puts 5 2's on the top and 2 2's on the bottom. We cancel out the matching pairs from the numerator on the denominator, leaving us with 3 2's on the top. This proves why you subtract the bottom exponent from the top one when dividing. When you are dealing with identical bases, you don't need to guess. Multiplying physically groups factors together, forcing you to add the exponents. Dividing cancels factors out, forcing you to subtract them. But what happens when you subtract an exponent down to 0 or push it completely into negative numbers? To find out, we look at the standard pattern. We know 2 to the 4th is 16, 2 to the 3rd is 8, squared is 4, and to the first power is 2. Every time the exponent drops by 1, we are simply taking our final answer and dividing it by 2. If we continue that exact pattern and divide 2 by 2, we prove that 2 to the power of 0 equals 1. We can push the pattern further. Taking 1 and dividing it by 2 gives us 1/2. This means 2 to the power of -1 is a fraction. If we drop down to an exponent of -3, we divide by 2 until we reach 1/8. Notice the negative exponent created a fraction, not a negative integer. A negative exponent is an instruction to take the reciprocal of the base. It tells you to move the base into the denominator, but it has absolutely nothing to do with making the actual number negative. We have the concepts and the rules. Now we test them by working through 3 examples, escalating from easy to advanced. Step 1. Calculate 3 to the 4th power. Identify your base of 3, check your exponent of 4, and multiply 3 by itself 4 times. This resolves to 81. Step 2. An intermediate multiplication. Because we have an identical base of 2, we apply our rule and add the exponents together. 3 plus 5 gives us 2 to the 8th power, which equals 256. Remember, when grouping identical bases, you add the exponents. Never multiply them. Step 3. The advanced problem. You have a power raised to another power in the numerator, sitting over a power in the denominator. Pause the video here and try to solve this by applying the rules we just proved. First, resolve the numerator. A power raised to another power means you multiply the exponents, giving you 2 to the 12th. Next, apply your division rule and subtract the bottom exponent from the top. 12 minus 5 gives you 2 to the 7th power, leaving a final answer of 128. Advanced math problems are rarely entirely new concepts. They are usually just basic rules stacked on top of each other, waiting for you to unstack them one by one. Here is your cheat sheet summarizing the 5 core rules. You can multiply identical bases by adding their exponents, divide them by subtracting, multiply the exponents for a power to a power, turn any base to the 0 power into a 1, and use a negative exponent to write a reciprocal fraction. Locking in these mechanics is a non-negotiable requirement for the math you are going to face next. For example, knowing how to square a number provides the conceptual foundation for square roots. A square root simply reverses the squaring process to find the original base. To make sure you have this foundation built, try solving these 3 practice problems on your screen right now and drop your final answers in the comments below. Mastering these mechanics provides the foundation for the patterns you will find in algebra, geometry, and trigonometry.